I turn on the power supply.
Alright, so what I've got in this fun little setup is I have these two masses, the brass and the lead, are now going to be suspended. Oops. These two masses are going to be suspended over this scale. So the two of them weigh. They weigh a lot. So 435 grams. Okay, so what I'm going to do is spin up these rotors underneath, put them underneath the two masses, like try one and the other, and see if there's any difference in weight. Just testing out the idea of gravitomagnetic induction. See if that might induce polarization in the weights and therefore momentarily alter their weight. Alright, so I'm going to try the lead one here, the lead rotor. Alright, sitting pretty there, 435.49, 46, 44, 43, I don't know why it's changing. Oh, who knows. 3, 4. Okay, so we'll see what happens here once I get this spun up. So I'm going to be underneath the brass one first. Now I'm going to go over to the lead one. So I'm about 5 millimeters from the bottom of the can. So just sitting there constantly. Now I'm going to pull it away downwards. And now I'm going to go up towards the brass one. And now I'm going to pull it away suddenly. back up towards the lead one. Now I'm going to pull it away suddenly. And now I'm going to try the same thing with the brass one. So I'm testing the lead rotor on brass and lead, and then the brass rotor on the brass and then the lead. So here we go, underneath the brass one, speeding up. Now I'm going to pull it away suddenly. 3, 2, 1, pull. Now I'm going to approach, and then pull away. 3, 2, 1, pull. Now over to the lead, weight, approaching, holding steady. Now I'm going to pull away. 3, 2, 1, pull. Approach. 3, 2, 1, pull. Alright, now I'm going to do the aluminum rotor. I won't be able to spin it as fast though, because it's off balance, which is unfortunate. Might not even be worth testing it. Okay, underneath the brass here. Here we go. Oh, here we go, fast. That's about... Okay, here we go, let's try that again. So I'm going to speed it up underneath the brass weight. Now we pull it away. 3, 2, 1, pull. Approach. 3, 2, 1, pull. Okay. Lead side, approach. 3, 2, 1, pull. Approach. 3, 2, 1, pull. Now I'm going to try and go faster. It's just really loud on the brass side here. Approaching. Three, 2, 1, pull. Approach. 3, 2, 1, pull. Lead side approach. 3, 2, 1, pull. Approach. 3, 2, 1, pull. Now I'm going to spin down. Spinning down underneath the lead side. Okay. That was fun. I'm just moving it across, back and forth. So the axis is horizontal. It's rotating horizontal to the ground. It's 14,000 RPM. I don't expect anything to happen with this. So here's just the rotating brass disc at about 1700 RPM, and there's a little plastic tray sitting there in another plastic tray with some water in it, and you can see the little paper thing moving around there. That's just some Teflon tape. It's got fluorine in it, so I thought fluorine atoms have a 1/2 nuclear spin, so I thought there'd be a good coupling there. And now I'm checking for magnetic field, which is showing 0, just to see, okay, is this a magnetic thing? And there's an aluminum cone. So here I've got the tray with brass chips in it, and this seemed to show a pretty strong rotational effect here, which was kind of puzzling because, well, you know, why would it something that's more massive be more easily rotated? So that's the question I had. So it weighs about 33 grams, that whole tray there. Here I wanted to try some manganese compounds, just for the same reasons as before. And this also had seemed like it had quite a strong rotational effect. And so what I did here is separate the motor, the kinemassic generator, from the tray so that there'd be no vibrational couplings there. Because and then I'm just putting some brass chips there and some water. And that's a piece of wax with the cobalt oxide powder in it. It tended to be drawn towards the center of rotation and even showed a little bit of torque, as you can see there, which was kind of interesting. And then there's, of course, it's responding a bit to a magnet. And I'm testing again for magnetic field. That's about 1 Gauss of magnetic field there, which was practically nothing. Here's a little bit of bismuth in a tray, showing a bit of rotation. Bit of copper, showing some rotation. That's a neodymium magnet. Now this experiment is pretty interesting because the magnet would tend to find its center there at the center of rotation of the disc, and then it would rotate with the disc for a while, and then it would stop, and then it would reverse direction. So I don't really have an explanation for that at this point. It's just an interesting observation. It seems to might have something to do with this theory, or it could be something more mundane. I'm gonna put another magnet on here. I took some of the fluid out of here too, so it'll be closer. And whatever field effect there is there will have a stronger coupling. And stronger coupling it did, it actually throws it right out. So it's probably too close. So I go back to one magnet and then I flip it over, and then it tends to repel away from the center, continuing to rotate. So here I go back to the first orientation there. So again, the magnet tries to find a center, but it's a bit off balance there. It gets thrown out. Now I add a bit of water to the tray there to make it higher up. So now it has a weaker coupling and finds its center there. So I just cut the power to the motor. So it loses its coupling when it stops. Here it goes again, speeding up. I'm just going to help it off the edge here. So one more little shot of this process here so you can see it. This is at 3 times speed, by the way. It's rotating with the disc, and now it stops, and then it begins to counter rotate. But then it comes to a place of being completely stationary, where it's not rotating at all. Now this is a piece of silver solder. So I just wanted to play with this silver solder here because it has the 1/2 nuclear spin. I thought that might couple pretty well to any kind of kinemassic or gravitomagnetic interaction field here. As you can see, it tends to hug the center, or I mean the periphery of the disc in rotation, which is interesting. Here's a piece of rubber, non-metal, just one, because anything gravitational would of course cause motion, cause torsional motion here, or rotation. So the weird thing about all this is it looks like it works with the theory that I'm presenting here, but there's this whole thing of these standing waves. So this little fan motor gave up the ghost and stopped working. So I decided to mount this flywheel onto this motor here, which I seem to be getting up to about 8,000 RPM on this, which is a lot better. So what I'm doing is seeing if I can induce any kind of action in this little tray of these brass chips. Here I'm just adding some brass chips and copper chips, and I noticed something very interesting about all these particles and how they're so attracted to each other. But it does have some nuclear magnetism. Well, I'm going to spin up this motor and put it nearby here and just see what happens to this pool of particles. Alright, so now there's no physical connection to this sample here. There's no air current connection. I'm just going to add some copper filings here. And they are strongly attracted to each other. Watch this. Maybe it'll get pulled right in. But all these particles have joined around the slab of wax here, with the cobalt in it, which is rich in hydrogen because of the paraffin. I'm going to add some sugar because sugar is rich in hydrogen as well. It's got a lot of. Well, thanks for your attention. I hope this has been interesting and informative. And check out the next video, which is a continuation of this, where I look at making things colder to see if I can enhance this effect. Thanks again.